Okay, it sure would be nice to have a hint on a problem like this. One thing I noticed about it, if I did choose a U substitution of problem, probably I would just choose a natural log of x because I do see its derivative in the problem. Let's write this down for you. So U equals the natural log of x, and du would be 1 over x dx. Let me write that down for you. And it looks doable at this point. So I'm seeing a 1. I'm seeing 1 plus the sine squared of u du. Now, granted, it's easier for me to look at, and certainly when I say it's easier to look at, that doesn't mean I can do it. I'm kind of looking at it, and wondering what to do in the problem. And this would take me some effort to get through, but it sure would be nice to have a hint on it. And so certainly, if I were a student said to me, "Oh, what's a good hint to start with?" I would say this is the best hint you could start with. Now, the student may come back 5 minutes later and say, "What would you do now?" I probably would give another hint, right? And the hint I'm going to give is I would say divide top and the bottom by the cosine squared. All right, let's take that hint. So you would get secant squared. Again, we're dividing top and bottom by cosine squared. Then you would get secant squared. And then, sine squared divided by cosine squared is going to be the tangent squared. All right, and then the student would say, well, what would you do now? And I probably would say, at this stage, I probably would not give you another hint, right? But I gave you 2 hints already. I gave you, take the u to be natural log of x, and then I said, after you did that, divide top and bottom of the fraction by the cosine squared. And now I'm looking at this thing and saying, maybe, I made a mistake too. I just noticed it. I'm so used to saying theta when I have trig problems. So I'm going to say let v equal, because I'm going to say it should be somewhat obvious what we're looking for now. So that v would equal the tangent of u. Now, why would I say that? dv would be secant squared. All right, put that down for you now. Put it over here. It's my second substitution. You get 1 dv. On bottom, you would get v squared here. And then the secant squared, that's really 1 plus the tangent squared, right? So it's going to be 1 plus v squared. Things are shaping up pretty nicely now, aren't they? So what do you get over here? 1 plus 2v squared dv. All right. Now again, remember, we start off with 2 kind of hints. And someone says, well, I don't know what to do with this guy over here. It should be somewhat recognizable. All right. Now what I mean by that, it sort of looks like an arctan problem to me. All right. So I'm going to make another substitution, by the way. And what I'm going to do, I'm going to rewrite this a little bit differently. That's going to be root 2v squared dv. And I'm going to say root 2v is equal to w. A lot of work, isn't it? By the way, dw is root 2 dv's. All right, let's write this down. So 1 plus w squared, and dv would be 1 over root 2 dw. I realize some people do that in their head. Nothing wrong with that. I tend to make mistakes when I do things in my head, though, by the way. It's going to be arctan w, some constant integration And I got to work my way backwards now. 1 over root 2. What's W? Oh, that's root 2V. All right, what was V? Oh, tan U. Sorry about that. So root 2 tan, just forgot what I just said, tan U plus C. What was U? Oh, natural log of X. Put a little box on this. Get my red pen out and see how we did. I'm seeing the root 2. I'm seeing the arctan. Seeing the root of 2. Seeing the tangent. Natural log of X plus C. Again, all typed up, nice and neat. Again, my chicken scratch may not look great to you. But anyway, it does work out. But again, I always say to myself, it's nice to have hints. And certainly, I don't mind giving hints. Thank you.